All right, so we looked at segment relationships in circles and how different line segments, if they're parts of chords or secants or tangents, um, how those relate to one another and how we can use certain rules and theorems to find missing parts. We're going to do the same thing with angles here. So this is angle relationships. And you can see there's a few different rules here, and I don't know if we really need to go over these all right here because we're going to look at each one of these by itself as we go along. But you'll notice the first one up here, this is just inscribed angles. And we know this already. If you have an inscribed angle, the measure of that angle is going to be exactly half the measure of the intercepted arc, of the arc that it creates. So you can see this example they have where the arc is 120 degrees and the inscribed angle is 60. One thing we haven't seen yet that works the same way is if you have an angle that is made from a secant line, so a line that intersects through the circle in 2 points, and a tangent line, which is one of those lines that just grazes the circle in 1 point. The same thing happens. You get an angle that is exactly half of the arc that it creates. So basically, anytime you have an angle whose vertex is on the circle, even if one of its sides doesn't go into the circle, it's always going to work this way. You look at the arc it creates, cut it in half, and that's going to tell you the measure of the angle. But we also have these two new rules. One you can see is if you have lines that intersect inside a circle and create, it'll create 4 angles inside the circle. And we know already that we're going to have a couple pairs of congruent angles because they're vertical angles. But also we have a way we can use the arcs, the 2 arcs that are created by these lines, to find the measure of those angles. And if you look at the formula here, it says to find the measure of this angle in the middle right here, we do 1/2 times the total of the 2 arcs. So in other words, you're taking an average of the arcs. You're adding them together and dividing by 2, and that'll tell you the angle in the middle. This other rule down here is kind of similar, and this is if you have an angle that's outside of the circle, either formed by 2 secant lines, and we saw this in the last lesson when we were dealing with line segments, or with a tangent and a secant. But when you get this angle outside the circle, again, you look at the 2 arcs that are created, but instead of adding them together, what you do is you subtract them, and then you still take 1/2. You still cut it in half after you do that. So rather than spend any more time here, let's get into the examples, and you can see how each of these rules is applied. So first off, we're going to skip that first rule for now since we've already done a lot of problems like that. We will get to one of those later. We're going to go to the second rule. This is where lines intersect inside a circle. And this example is asking us to find x, which is this angle right here. So to do that, we look at the 2 arcs that are created by these intersecting lines. So we have the 32-degree arc, the 54-degree arc. What we're going to do is add those together and then cut them in half. So x is going to be 1/2 of 32 plus 54. And so if we add 32 and 54, we will get 86. And we just take half of 86. Just chop it in half, divide it by 2, you get 43. So x is a 43-degree angle. So again, you look at the 2 arcs and you just average them. You add them together and then multiply by 1/2 or divide by 2. So it's 43-degree angle there. And once you know that, you can find the other angles in the middle here. We know if this is 43, then this angle right here is also 43 because they're vertical angles. And then if you want to subtract from 180, you could find these other 2 angles as well. But for now, let's go ahead and keep going and look at some different examples. Here, they give you the angle on the inside. They tell us this angle is 72. And they tell us one of the arcs that's created by these intersecting lines. It's 99. And what we want to know here is, what is this other arc? So here what we have to do is think, we already know the angle in the middle. So if you look at this formula here, for example, we'd already know angle 1 in this situation. So we know 72. is equal to 1/2 times those two arcs added together. So it's going to be times 99 plus x. There's different ways to work this out. Me personally, I like to get rid of fractions right away. I don't want to deal with them any more than I have to. So what I'm going to do first is I'm going to multiply both sides of the equation, so everything by 2. The reason I'm multiplying by 2 is because 2 and 1/2 cancel each other out. And that gets rid of my fraction. And so now what I do, I multiply by 2 on the other side. 2 times 72 is 144 equals, and all I have left on the right is 99 plus x. So if I multiply by 2, I don't have to distribute a 1/2. I don't have to worry about fractions. All I have to do is subtract 99 from each side, and I have my answer. So 144 minus 99 is 45. So x is 45 degrees. So I would recommend doing that when you're looking for one of the arcs and you'll have 1/2 times a parentheses with the x inside it. I would multiply by 2, cancel out the 1/2. That's going to make your x that much easier to solve for. All right, example 3. Same rule, same idea, except we know the angle already in the middle is 100. We got to find information about the arcs, but instead of just solving for one of the arcs, we've got expressions for both of these arcs. So we don't know what either arc is. It's asking us to find the length of BC, but to do that, we've got to figure out what x is. So we're going to go ahead and set this up. We're going to start with 100. That's the angle in the middle. Equals 1/2. And then we're just going to add our two arcs together with what they've given us. So one arc is 5x plus 7x plus 8. And I'm going to combine my like terms in the parentheses there. 5x and 7x is 12x plus 8. That's equal to 100. Again, I want to get rid of that 1/2, so I'm going to multiply both sides by 2. That cancels out the 1/2 on the right. On the left, it gives me 200. So I have 200 equals 12x plus 8. Now I just have a two-step equation. I'll subtract 8 from both sides. I get 192 equals 12x. So I divide by 12, and I worked this out earlier, but I'm forgetting my answer, so I'm just going to do this over the side. 192 divided by 12, and looks like it goes in there 16 times. So x here is equal to 16. Now, one thing you have to keep in mind, as we often do in geometry, is that x isn't always the answer we're looking for. And here, it doesn't want x, it wants the length of BC. So my last step is I have to look at arc BC over here. It tells me this arc is 5x. So what do is I take my value of x, which is 16, and I plug it in there. I get 5 times 16, and that's going to give me 80. So the measure of this arc that I'm looking for is 80 degrees. So same idea, just a little more complicated, a few more steps, but same basic idea. All right, let's move on to that other rule where the angle's outside the circle. And so here we want to find the measure of angle DAB. So DAB is this angle right here. That's what we're looking for. Let's give it a name. Let's just call it x. It's going to make it a little easier if we have a variable. So now I'm looking at my formula for this. And what you do here is you still multiply by 1/2. But instead of adding the two arcs together and taking their average, you subtract the two arcs. So what we're going to do here is we're going to start with the angle x equals 1/2. Then we're going to take the two arcs and subtract them. You always want to start with the biggest arc, which is, in this case, 100, minus the smaller one. And then I'm just going to, I could multiply by 2, but I don't really need to here because I can just work this out. 100 minus 30 is 70. And now I have 1/2 times 70, or half of 70 is 35. So x is equal to 35 degrees. So this ends up being a 35-degree angle. All right. Here's one that's a little more complicated. Here they give us the angle that we start with. So we're starting with 30 here. So we don't have to find the angle. We've got to find x. And that's all we have to do. We don't have to plug it back in on this one. We just have to find x. So we have 30 equals, and again, it's going to be 1/2. And actually, here's what I'm going to do. I started making a parentheses, but I'm actually, because you really have to be careful on these, on the ones like this. I'm going to go ahead, instead of doing a parentheses, I'm going to do a bracket, and I'm going to put 2 sets of parentheses in there, because what I have to do is take my big angle, 5x minus 10, or 5x plus 10, I'm sorry, 5x plus 10, minus my little arc, or I think I said angle for 5x plus 10. It's an arc. I take my big arc minus my little arc, which is 3x plus 4. And I got to be really careful here because I'm not just subtracting a number, I'm subtracting an expression. So when I work this out, and I take these out of their parentheses, the first parentheses is fine. It's just 5x plus 10. The second parentheses is being subtracted, and you may remember when you subtract a whole expression in parentheses, you're subtracting each term. So you kind of like distribute that minus sign. So you're going to have minus 3x, and then you're also going to have minus 4. So be very careful when you're subtracting something in parentheses that you end up subtracting all the terms inside the parentheses. I'm going to go ahead and just keep working inside these brackets and go ahead and combine my like terms. So I got 5x and a minus 3x. That's going to give me 2x. I have a 10 and a minus 4. 10 minus 4 gives me 6. So I get 2x plus 6. So a little bit of work to get there. Now that I'm here, I'm going to do what I did on some of those earlier problems. I'm going to get rid of my fraction because I don't want to have to distribute a 1/2, although it kind of worked out nicely on this one. But just in general, I don't like to do that. I'm just going to multiply by 2 to get rid of it. When I do that, 2 times 30 is 60 equals 2x plus 6. And now I just have this little equation I can solve. I'm going to subtract 6 from both sides. I have 54 equals 2x. I'm going to move that over here. 54 equals 2x. Divide it by 2. And 27 is what x is equal to. So x is 27. So a bit of work on that one, but the big thing is just be really careful when you're subtracting an arc or an angle that's in parentheses like this that has more than one term. Make sure you end up subtracting both of the terms inside the parentheses. All right, a couple more. Here, the nice thing is the numbers are a lot simpler now, but it looks a little different. I just wanted to look at one of these to show you that even though it looks different, it works the same way. What we have here is, on the bottom here from A to D, this is just a secant, just like we had on the previous 2 examples. On the top, though, this is a tangent line. It doesn't cross through the circle. It just grazes the circle, it hits it at one point. But it's okay. It's still going to work out the same way. So we're going to take we're trying to find this angle up here, CAB. That's this angle here. And I'm going to call it x. So I'm going to start with x like we did a couple problems back. Start with the angle. I'm going to take my 2 arcs. I'm going to do 1/2. Take the big one, 164, minus the little one. So this will work out really nicely. I just wanted to show you one where one of the lines was a tangent, just so you could see that it works out the exact same way. You subtract the 2 arcs, you take 1/2, and that's going to tell you the angle. So let's go ahead and finish this. 164 minus 70 is 94. Then we'll take half of 94. That's going to give us 47. So x here is 47 degrees. We have a 47-degree angle. All right, one more example. And this one also not too bad. And also just because I want to show you one that looks like this. This is that very first rule, and it's the same thing we already did with inscribed angles. So here we have an angle that has a vertex on the circle. And this is a little different than the ones we worked with before, because instead of that other side of the angle crossing through the circle, it goes outside the circle because it's a tangent line. And when it does that, it creates an arc, which is 148 degrees, this arc right here. And we want to find the angle x. Well, to do that, we do the exact same thing we did with our inscribed angles. We take 148, the arc, we divide it by 2, gives us 74. And so 74 is the measure of our angle. It's 74 degrees. So pretty straightforward. Don't have to do much work on this, but it does look a little different than the ones like that we've seen before. So I just wanted to show you one so when it comes up, you know what to do there. So those are our angle rules. There are 3 of them that you'll have to keep straight. So there you go.